what's up guys, my name is Cherno and welcome back to my C++ series. Today we're going to continue on our whole object-oriented programming, classes, all of that stuff, and we're going to talk about constructors in C++. So, what is a constructor? A constructor is basically a special type of method which runs every time we instantiate an object. So I think this is best described with an example. Suppose that we want to create an entity class. Let's actually dive into some code and take a look. We want to create an entity class here, which has two members. Perhaps it has a float x and a float y, which is basically just describing the position of the entity. If I try and create this entity and then perhaps maybe give it a print function so that it can output what it is into the console, I'll just print x and have a nice little separator comma between the two, then y. I'm instantiating the entity here, and then I'm going to call the print function. If I try and run this code, you can see that it will work. However, I get seemingly random values for the position of this entity. And that is because when we instantiated this entity and allocated memory for it, we didn't actually initialize that memory, meaning that we got whatever was left over in that memory space. What we probably want to do is actually initialize the memory and set it to 0 or something like that, so that our position is 0 by default if we don't specify or set a position. In the future, I'm going to make an in-depth video about initialization for classes and all of that, so I'm going to keep it brief here. But another great example is if we decide to manually print x and y. They're public, so we can go ahead and try and write code which prints out x, for example, e.x. If we try and compile this code, you can see that we get an uninitialized local variable e_used error message. So in other words, this code will not even compile because we're trying to use memory that has not been initialized. This print function does compile, however, but it doesn't work the way that we expect it to, of course, because it's printing x and y, however, they are set to seemingly random values. So we've already got a need for some kind of initialization. We need a way to, every time we construct an entity, we want to be able to set x and y to 0, unless we've specified some value. So what you might want to do that is create an init method. So I'll create a method called init, it'll just be void, and it will just take the job of setting x and y to 0. Now, what I can do is, when my entity gets constructed, I can call e.init, and then if I try and print my values, you can see that I get 0, and then when I call print, I get 0, 0 printing, meaning that x and y are set to 0. Wonderful. However, this is quite a bit of code that we've written extra. We've had to define this init method, and every time we want to create an entity in our code, it means that we have to actually run that init function. That is quite a lot of extra code and definitely not clean. So if only there was a way for us to run this initialization code when we construct an entity. In comes the constructor. So the constructor is a special type of method which is basically this. It's a method that gets called every time you construct an object. To define it, we define it like any other method. However, it does not have a return type, and its name must match the name of the class. If I want to construct it for entity, I just type in the name of the class, which is entity. I can optionally give it parameters, which we'll talk about in a second, or I can leave it blank, and then I can just give it a body. And in this case, I can set x to be 0 and y to be 0 as well. We can get rid of this init method, and if we scroll down here, we don't need to call init anymore at all. If I run my code now, you can see that we get an identical result to what we had when we ran the init method. However, now we don't need the init method. It's handled for us by the constructor. If you don't specify a constructor, you still have a constructor. It's just something called a default constructor. It's actually provided for you by default. However, that constructor doesn't actually do anything. It's basically equivalent to this. It does nothing. So don't think that it initializes your variables at all. In languages such as Java, primitive types like ints or floats are automatically initialized and set to 0. That is not the case in C++. You have to manually initialize all of your primitive types. Otherwise, they will be set to whatever was left over in that memory. So very, very important that you don't forget about initialization. Again, I'm going to talk more about initialization in a future video and different strategies and ways to initialize memory correctly. So definitely check that out whenever I get around to making that. Let's take a look at a constructor with parameters. So I can write as many constructors as I want, of course, provided they have different parameters. This is the same as if I was writing methods with the same name, however, providing different overloads for them. So basically different versions of the same method with different parameters. I'm going to add x and y as a parameter here, and I'm going to assign x and y to x and y. So basically I'm assigning my parameter to my member variable here. I now have the option of constructing entity with parameters. So I simply write whatever I want my values to be, such as 10 and 5. I'll get rid of this extra print. And if I run this, I should of course get 10 and 5 printing to the console like so. Alright, cool. That's constructors pretty much covered. Constructors, of course, will not run if you do not instantiate an object. So if you just use static methods from a class, it won't run. We haven't talked about heap allocation yet. We definitely will in a future video, probably really soon. But of course, when you use the new keyword and create an object instance, it will also call the constructor. There are ways to remove a constructor as well. If, for example, you had a log class which you only had static methods in. So for example, I had my static void log here. Let's call it something like write instead and not be silly. And I only wanted to allow people to use my class like so. I did not want people creating instances. There's two different strategies for sorting that out. We can either hide the constructor by making it private like so. And you can see that I get an error here because I cannot access the constructor. If I don't do something like that, you can see it obviously allows the construction of this object because C++ supplies a default constructor for us. However, we can tell the compiler, no, I don't want that default constructor. And we can do so by simply writing log, which is our default constructor, equals delete. And if you look over here, we cannot call log like this because the default constructor doesn't actually exist, it's deleted. There are also special types of constructors such as the copy constructor and the move constructor. There are going to be separate videos on each of those because they're rather complicated. But for the basic use, that is what a constructor is, a special method which runs whenever you create an instance of a class. The primary use for this is to initialize that class. Make sure that you initialize all of your memory and do any kind of setup that you need to do whenever you create a new object instance. Oh, we've got so much stuff to cover. I'll see you guys next time. Goodbye.